All right, we're in our student companion notebook. We're in lesson 8-4. That is page 238. So hopefully you're on page 238 in your student companion notebook. So note, multiplying special cases. So we've been talking about multiplying polynomials. Everybody loves multiplying polynomials. So again, as always, we're going to do a quick review. So circle the square numbers. So remember, a square is like 4 times 4 is 16. So 4 squared would be 16. 16 is a perfect square. So which one of these numbers are squares? So 36, that's 6 times 6. 144. 1/4, because that's 1/2 times 1/2. And remember that 1 squared is 1. Now 6, again, it's 6 times 2. It's not multiplying by itself. So that one doesn't count. So moving on, underline the correct word or words to complete each sentence. The square of a non-zero number is always positive, right? Always positive. So the square root of a number is sometimes negative. It depends on what the number is, right? All right, so our vocab word, binomial, square of a binomial. So a binomial is a polynomial with 2 terms, okay? Bi means 2. So we've been talking about binomials for over a week, so that really should have just been a quick review of that vocab word. So cross out the expression that is not a binomial. So which one has 2 terms? Well, clearly this one has 2 terms. This one has 1, 2, 3 terms. So hence not a binomial. This one has 2 terms and again 2 terms. So write your own examples of binomials. All right, so I can do that. Binomial 3 minus a, right? That has 2 terms. P plus Q. 17t plus G. Or 100s plus 200r. All are binomials, right? So use the words in the box at the right to complete the graphic organizer below, and then write your own examples for each type of polynomial. All right, so obviously this monomial, trinomial, binomial, they are all examples of a polynomial, right? So we use that. So there's a monomial, a binomial. This is 1. This is 2. 3 would be a trinomial, right? 1, 2, and 3. So an example of each would be a monomial would be, so you can see what I'm going to do here. A monomial would be like x squared. A binomial, x squared plus 2x, and a trinomial, x squared minus 2x plus 4, right? Sure. Let's turn the page. 239 is what you should be on. So key concept, the square of a binomial. So let's say we have a problem. And the math problem says a plus b squared. So that's in parentheses. This actually means the same as a plus b times a plus b. When it's squared, it means the same as that. Okay? So how do I do that? Well, you're going to get, again, we would use FOIL, box method, or distributive property. I don't care which you do. But you have to do one of those. So if we do x minus 7, right? X times x is x squared. Then we have outside minus 7x. That's minus 14x. And then last is plus 49. 7 times 7 is 49. Okay? So you're going to do the same thing right here. X plus 9. So first is x squared plus 9x plus 9x, so plus 18x, and then 9 times 9 is 81, right? Those were just really quick versions of FOIL. Now, squaring a binomial, what is the simpler form of n minus 7 squared? Again, circle the rule that you would use to square the binomial. You're going to use this. So what it says is that when it's negative, you're going to have a squared. Then you're going to have 2ab plus b squared. Okay, true. So if we substitute n for a and 7 for b, then simplify. So we have here, well, we're going to do two problems. So a minus b squared. So that becomes 7, right? So we have n minus 7 squared. It equals n squared minus 2n times 7 plus 7 squared. Very, very confusing. So you see, if I literally just do n times 7, n minus 7, and I multiply, then I know I can do that n squared, right? Outer, inner, minus 7n plus 49, right? Easier than this. This is the way that is easiest. That is the way that we know, right? All you have to do is write it twice. Squared means it's this 2 times. I know that. Combine like terms, n squared minus 14n plus 49, right? You'll get that if I do it this way. You will. You'll get the same answer. It's just a whole new equation to where if you just write it like this, you can do it the way that you all know how to do it, correct? So again, we're going to write it. This is one way. This is the formula that the book is showing you, but I'm telling you, this is the easier way to do it. This is the way you know, okay? So we're going to skip applying squaring of a binomial. The issue is the things that we're learning when it's squared, you may have to worry about, like making an outdoor patio and you're going to have a brick walkway around the patio or on parts of the patio. Then you have to know how big it is. So squaring something is truly going to help you do that. So that's why we learn this stuff. So now you're moving on to problem 3. And again, this is just a quick review of square. So what is 85 squares? Well, I don't make you do mental math, but let's say you did. What number is closest to 85? Well, what number can I square mentally? It's right between 80 and 90, right? So choose a number close to 85 that you can square easily, right? 85 is a binomial, square the binomial, now simplify. So depending on how you would do that, to square 85, let's say I thought 80 times 80 would work. 8 times 8 is what? 160, right? You can use your calculator. So this is a way that you could do it if indeed you needed to. So that's 8 times 8 is 64. So that would be 6. I think I just added them earlier. So that'd be 6,400. Then you have, you would have to do 80 times 5. So then that would be adding, 400. Again, we're better off if they asked us to do it. See how this is going to be much easier than using the formula that they're giving, okay? Same as what we did here when you have a plus b, a minus b. you're going to end up with a squared minus b squared. But you still do FOIL or box or distributive property. See where the book is showing you that there are other ways, but they require more steps and memorizing another equation. Doing FOIL, multiplying two binomials, is something that you're familiar with and comfortable with. So here, go back to what you know. So if you know the box method, still make your box. X and 2, X and -2, right? If you're comfortable with FOIL, then you're doing FOIL, right? It's whatever way you're most comfortable with. The point here is that you understand that even when you're asked to do something in a different way or you're given a different way, always go with the way of which you're most comfortable. So all of this, you can do the box or FOIL. It doesn't matter. All of it will work. Or if you do distributive property, certainly you could do that. So here, if we did FOIL, it's r squared, right? R squared, and then we have outer, so -6r, inner, plus 6r, and last -36. So this eliminates, and you get r squared minus 36. So that is the answer you'll get, but you'll still go about it. FOIL or box method, whichever works best for you, is how you're going to do that, right? So what is the simplest form of x plus 9, x minus 9? So circle the rule to simplify. All right, so you can't do this because 1's plus and 1's minus. Can't do this because 1's plus, 1's minus. So clearly, that's what we're going to do, right? So we're going to say x plus 9, x minus 9. If I do the box, right, I have x and 9. I have x and -9. So x squared minus 9x plus 9x minus 81. If I do FOIL, first, outside, inside, last. Okay, either way, the middle crosses out and you get x squared minus 81. This is going to be your final answer. Again, all of the examples, even though they gave me a more difficult or a different equation, we can simply say it's going to be, right, FOIL, box method, or distributive property. You're going to use them the same. If it shows like this, you just write it A plus B times A plus B. See you in class.